Hello, everyone, and welcome back to the Platypus Theatre at PyConline 2021. Next up, we have Sam Bishop with Snakes All the Way Down, building worlds with Python code. Sam is a professional software developer, amateur rocket scientist, and astronomer. He loves Python, Django, cats, working on personal software and hardware projects, everything space, playing games of all kinds, and tinkering with 3D printers. Take it away.
Hi, my name's Sam. I'm presenting this talk, and there is a lot in it. So if you have any questions that you don't think of during the talk, feel free to follow up with me on any of the things listed there. It's going to be a bit of a rush in places, but I think there should be enough time to get through everything. So we'll start off with Faker. Now, if you're trying to get some random data, you may have already come across this for testing or any of these other kind of scenarios. It's even got a PyTest plugin, so it's pretty common to see this in many projects. It lets you generate all kinds of fake information, names, jobs, credit cards, whole profiles even. It's very powerful and a lot of data in it. It's got more data than you'd think. It has a number of plugins that allow you to generate extra things like social security numbers, ISBN books, all these via a community of plugins. It's got localization and the ability to get all kinds of extra character sets and things like that. And interestingly, compared to the next one, the ability to do unique sets, which is handy if you want to get a whole bunch of things and not have any overlap. Then we've got Mimesis. Now, Mimesis is a fast data generator. So if you're going to be generating lots and lots and don't mind about things like uniqueness, you can actually use it to get a very large amount of fake data cooked up for whatever you're trying to build, fake census, I want thousands of names or jobs or cars. So it can turn out a lot of interesting information that others don't have. Things like political views, occupations. It's got the addresses and good old geography. It can even do food, which isn't something in Faker and a few of the other ones. So we've got drinks and ingredients and dishes. We've got our trucks that I mentioned earlier. We've also got cars and airplanes. Those of you who are a bit of an airplane nerd may have spotted two that don't exist. So it is actually making completely fake airplanes. There is no such thing as an Airbus 550. Then we've got phones, a whole bunch of fake phones, a couple of real phones you might notice. We've got CPUs, GPUs, fake resolutions. Well, they're real, but it made them up. We've got programming languages, OS licenses, operating system names. It's got a very comprehensive set of things that it can generate for you. Now, not all of this is the kind of stuff you're going to think of getting when you're trying to make some kind of creative content, but if you're trying to think of something in the middle of writing and get stuck, it's a great way to sort of unblock if you need like a name of a person while you're writing out a story and can't think of anything. You can reach for a tool like this and just say, give me a name, give me a job, give me a place, and it can really push through that kind of scenario. It has a bunch of locale aware settings, so you can ask it to generate everything in a specific locale, like E in US or English spellings, or in French and German, and a whole bunch of other countries. It's got some country-specific generators to do things like, I want a European ID number. I think it's got a number of different European countries' ID number generators in there, and a schema-based tool to actually create specific generators for your own purpose. It's definitely worth looking at if you've not looked at it before. Now, on from that, there's some more focused tools that I've come across and put in this presentation. So we've got Seraph's NanoGenmo entry from 2014. And in case you didn't know what it was, NanoGenmo was this contest, kind of like NaNoWriMo, where they were trying to generate the content. And Seraph's entry was pretty impressive. He built a complete Voynich manuscript generator. So he took a bunch of random text generators, ran them through a Voynich font, and produced a whole book that can just be poked and produced randomly variations on, and his book is this version, but you can use the tool to generate your own version of this quite easily. And it's a very impressive output. So if you're, building up some kind of a world and want like mystery text content, cryptic cipher stuff, it's very pretty and very impressive. Yeah, he's pulling it using the Flickr API, doing some basic image conversions and processing to sort of color match backgrounds and match into a font. It's very impressive and worth a read. He's put it all online in those links that you saw in the earlier slides. Okay, on from that, we've got the Pantheon generator. Now, this one's really fun. I'm going to do it as an interactive demo. So here we're just pulling it in and we'll fire it off. So we'll get that started. We've loaded it up. We'll get a first god. We'll get a second god. Now, the way this works is you have to have ones that are biologically set based, because this is a genetic programming tool. So we need not a male and a female, but an XX and an XY. It actually has a bunch of stuff under the hood where there's separates between gender and sex, and it's really fascinating when you actually lift up and have a look how it's combining multiple attributes. So we've got our two primary gods to start things off. We'll make our pantheon, and then we'll ask it to spawn 10 generations of gods out of this pantheon. And so it's going to create a whole sequence of gods for us. And so we get a whole bunch of them progressing down, losing their powers as they sort of get younger and further down, in the way that a lot of sort of classic sort of Greek and Roman sort of era stuff tends to have. So once that's done producing our 10 generations, I'll sort of scroll up and show a few more of the interesting ones along the way. So it's a fairly large pantheon here, obviously. These gods have been very busy. Yep. Okay. So if you look further back up into the top, you see that all of them are very much gods to begin with. But as you progress, it starts smattering in these ones that are sort of partial. It's crossbreeding and sort of losing the powers in that sort of gradual sense. So we've got our demigoddesses and demigods, and then we've got further down here there was a semi-divine, and then right down to an ordinary woman. So it's this progress of becoming a very Greek sort of myth pantheon here. But it's all sort of built off the back of this, taking each generation, combining them, and then producing an output iteratively, giving us this rich pantheon. So we end up with all these different ones with their various hierarchies. And just to sort of illustrate a little bit more how it's actually built this whole pantheon with all the connections, whose parents and all the relationships, we'll just graph it out. Has to think for a minute while it sort of graphs that out. So as you can see, it's a very, very rich set of connections here with all the various intergenerational steps and relationships between them all, and whose parents produced which. And all of this is available in that library. It's quite a powerful tool to sort of create this kind of basic world building background material for either a story or a game. So moving on. All right, so now the Earth-like procedural planet generator can produce some really awesome output. It can produce a bunch of textures for making your own 3D workflow, or it can actually just render out a movie for you. And I've put two different seed values in here to show how we get two different distinct planets based on that input. It takes a little while to render these, but they come out looking pretty nice if you ask me. So on that point, there's another planet generator. Now, another planet generator. Now, this one produces an actual whole 3D world. So this is all sort of done in Plotly, but it's actually producing a height map for the whole world based on its input. And you could easily convert this into whatever format you want, since his tool produces just the raw grid, and you can just work with it from that point. So after that Planet Generator, we've got our crossword composer. So this actually generates a crossword based on a word list. And so it's got a little GUI. It allows you to sort of fire that up. You can put them in there and it'll actually crunch out a crossword puzzle based on the words and the grid. And here's a little example of it actually running. So you can see how it's taking the words that it's modifying and fitting them in so that they have to match up with each other. And then you'd obviously take those words and sort of make up your own questions if you were actually making a crossword with it. So we've got our spaceship generator. Now, the spaceship generator is a Blender plugin, and it's a relatively easy one to use. You just pop in here and then you can just go in and you can add a spaceship. Easy as that. But what's interesting is the variety you can get. So you can get a number of different outputs based on just the input being completely random. It doesn't ask for any parameters. You just give me a spaceship. And it produces an actual completed object with the colors, little bits on it. You can see it's got things like antennas and little arrays and guns and engines. And it's very impressive how much detail is being placed into these. And they're completely randomly generated. So it's trivial to start using. It's definitely quite an impressive free plugin produced by someone who put a bit of time into actually making something come out really well with very little effort, and a very wide variety of outputs, from the long, sort of narrow. It's a very impressive plugin. So I'll just stop that. I'm not a big heavy Blender user. So after the spaceship generator, we've got the tree generator. Now, the tree generator is another Blender plugin. It's for procedurally creating trees. Now, there's a lot of power in this. It's very complex. It was actually produced as part of someone's undergraduate dissertation, and it's able to take just standard inputs and produce a variety of different trees based on that. So I've gotten with some bamboo here to show some variation, but if we customize the parameters, we can actually end up controlling that growth. So do we want a shorter plant, a taller plant, or do we want one that's not going to spread out as much? Now, that keeping it less spread out sort of makes it look less like bamboo, and this becomes more important with other trees where you want to be able to control their growth. It takes a while to sort of render these out and sort of construct them. It doesn't texture them, so they come out without any colors, but without a lot of work, it's possible to actually produce some very impressive results. I asked someone who knows how to do all the sort of Blender coloring and texturing and shaders and stuff, and they were, without a lot of work, able to sort of convert this out in one day. So they produced this absolutely marvelous, this marvelous Cambridge oak from just a few hours to color that up, and most of that was just working out what I'd handed them. They said it was pretty easy, and they did that with no complex text. It's just basically the 3D equivalent of the old paint bucket fill in Photoshop or Paint, and it comes out looking pretty impressive. So it's a very powerful plugin, and if you need to generate anything tree plant-like, worth looking at. So we've got World Engine. Now this one is a big one. So I keep going past this page, and you may have been wondering what it is. What it is a full plate tectonic planet generations tool. So what we've got is a variety of biomes, oceans, hydrology, precipitation, temperatures, and it allows you to generate these and save them off. So here's one I've already got generated, and you can see that it's got our temperature banding. We've got average global temperatures. We've got things where higher terrain are not actually being as warm. We've got some rain shadowing on similar things if we switch back to the precipitation view. It's pulling this in from a 100 meg protobuf file, so bear with me. You can see how some of these landforms are actually producing rain shadows. It's an incredibly detailed simulation, and it's quite powerful to be able to create these things. It does a full biome. It actually allows you to sort of plot out how much of the planet is covered by various biome types, but the more useful one is actually just the biome view itself, which gives you a sort of layout of what all the different biome areas look like. And you can do a satellite view that sort of shows you what does this look like in real color. Just wait for that one to pull itself up. But this one starts out with an actual plate tectonic simulation. So it generates a bunch of landforms and then does a physics simulation of them colliding with each other to sort of build up the continental crust and the ocean crust. And you put in how many plates you want, and it does a number of iterations. And it's actually the slowest part of this process. It takes a lot longer to do the plate simulation than it does to do anything else. Yeah, this is one of the larger files I generated. It produces a lot more detail in terms of rivers and things like that, so it might take a while to load that one up, but if it keeps going, we'll skip on past it since we don't have time to waste. Yeah, I think that might be stuck there, so we'll skip over it. But it is online. I've produced a fork of that one, so if you want to look for that one in mine, it's definitely worth a look at. Yeah, there we go. So you can see that it's produced the coloured terrain there, and we've got our deserts, and we've got the river valleys, and all the various places there. Okay, so after that, how are these actually put together? So what is under the hood of these Python tools? Because obviously it's one thing to look at them and see, oh wow, it did that. But if you wanted to either modify one of these or build your own, where do you even start? So the first few I showed are they're randomness. I mean, everyone sort of starting out does the pick one from a list kind of basic random choice problems, and that's what they're built up for. Even Seraph's NanoGenMo entry is heavily built with randomness. It's added to that with the image processing and matching the colors, but under the hood, it's very much go to the Flickr API, get a bunch of random pictures, pick some random pictures. Pick some random text, adjust it to match the font, put that in. It's still randomness being driving that process. So you can go quite a long way with just randomness, but then you need to step that up if you want to create richer things. So you get into the genetic algorithms, which is what was in the Pantheon generator. So that actually takes these things and it combines them. You know, there's a complex set of things that are and aren't genetic algorithms, but in essence, what they are is that process of taking the properties of one generation, mixing them, and producing a new generation. And whether or not that is one kind or another really isn't important at this level. It's a very powerful way for you to get a combination output, you know, take properties of multiple things and produce a whole plethora of outcomes that gives you things like that whole graph we saw where from just two inputs we ended up with hundreds of different gods, all with their own various little domains and specialties. You know, we went from at the very top, we started out with, you know, Lane, goddess of specialties, premises and defects, and down near the end we've got ourselves one at random, we've got Curtis, god of depends. You know, it's going from there to the other end of it is a generative process, and the genetic algorithm is a great way to build that. On top of that, we've got noise processors. This is sort of the bread and butter. The noise processors are a way you would have seen with the visual tools. So these are heavily built on noise processors, and this is entirely driven by noise processors. So I'll cover three noise processors. We've got the Diamond Square. It's the simplest. It's also one of the oldest. That is the whole program right there. So when you adjust the property, which it only has one, it just has the F property, what you end up with is a variety of noises. So they random, and then if we actually change those up or down, we change the scale of that randomness. So that's slightly less coarse, and if we change it down again, it gets even less coarse, and if we go all the way down to there, you can see how it's a very smooth, very, very spread out randomness. So onto that, we've got Perlin noise, which is what that is. This is entirely Perlin noise. And Perlin noise was invented by Ken Perlin, hence the name. It is a fairly simple noise process. So I'm not going to show the actual implementation. It takes a whole screen, not worth really showing. But Perlin noise is fairly understandable. So you change the parameters, and what you end up with is you end up with changes in the noise. So it is pseudo-random. It does depend on the inputs. It won't generate different noise without changing those inputs. But if you do change those inputs, you can adjust what you get in terms of the output. If we make the area bigger, even if the ratios are the same, we get different inputs. But if we actually increase the area, you'll notice that it doesn't actually change. That's a double size picture. The grid is twice as big, but the noise is the same, just more blended out, because that's one of the parameters that changes the noise versus the data output. And Perlin noise is one of the staples. It's used in a lot of places. Stepping up from Perlin noise is simplex and open simplex noise. And now open simplex noise is one of the more interesting ones, in it's n-dimensional. You can generate multiple dimensions beyond just 2D and 1D noise. You can go into 3D and 4D noise, changing over time and volumes. I'm not going to dig too much into simplex itself, because open simplex is the one that I can actually really show you and get into. And that's the whole thing. I'm not going to bother trying to even explain the process. That is literally the most readable implementation I could find. It's a bigger algorithm than you'd think, and it's pretty powerful. So if you do want to dig into it, there is a fantastic paper by Stefan Gustafsson on simplex noise, which is directly applicable to open simplex as well, because once you understand how they work by getting to the end of the paper, you'll see that it's pretty much just flipping around which way they work. It's a weird way, but patterns, Let's see it in use. So what we have here is we have some open simplex noise. It's just chucked in the parameters there, obviously setting it up there, and the feature size is set to 24 pixels, so we get noise of this size. Now if we halve that, the noise gets more grainy. It's being shrunk effectively, and if we change it to an even smaller one, we get another step. So what we have here is we've halved the size and set that down to 8. Now if we shrink it, you can see it's getting quite grainy and granular, but at the same time, it's one of these things that lets you control what texture you get out of the noise process. And tuning these parameters is the skill in using the noise process. It's basically what you can use to actually control how the output is useful to you. This is a version I've run through NumPy, which will make sense in a second, because what you're also able to do is you're able to run this in a vectorized fashion. You can run this in parallel. Now, might not seem too relevant to start with, but when you want to generate thousands of pixels worth of it, it starts to become relevant. Or, as I just did here, when you want to be able to do it in 3 or 4 dimensions. NumPy is a lot better at that than a couple of for loops. So I've turned a 3D array into a GIF here, so you can think of it as panning up through the layers of noise, and you can see how that noise pattern is smoothly evolving up through the layers. The areas that are black and white are moving contiguously. They're not just moving completely at random. So moving on from the open simplex noise, we've got constraint solving. Now, if constraint solving sounds unfamiliar, you probably have come across it and not even known about it. These are constraint solving games that people do fairly often. Crosswords are another example of constraint solving games. And human brains are really good at this without even thinking. Scrabble, again, a constraint solving game. But constraint solving problems are pretty complicated. It's one of the things that's hard to teach a computer how to do. It is a whole area of study, and if you really want to dig into understanding it, I'd recommend starting on the Wikipedia page, finding the specific topics you want to sort of study, and digging into them that way. So on top of that, there's wave function collapse. Now, wave function collapse is a really awesome algorithm that lets you take sort of starting seed samples and it sort of generates out stuff based on those seed samples. A good example there on the slide, we've got the little plant, sample goes in and you get varieties of plants coming out after it by tiling and moving across the algorithm. It's a pretty interesting algorithm that's worth sort of reading through. It would honestly be a whole presentation by itself, and I can only really sort of show you the high level example here of how it sort of iteratively builds up that process. There's a fantastic explanation there by Robert Heaton. I definitely recommend reading that if you want to understand how this works. It's a really, really easy to follow explanation. It just would take more time than I have in this talk to actually walk you through it by hand. But his excellent Python code goes with it. And it's really awesome. As you can see from the output in that GIF there, you can do so much with this algorithm. It's fantastic. Now, after that one, we get to the big one. Generative adversarial networks, which are a bit of a topic at the moment because they're being used for lots and lots of things now. You may have seen a number of things out there at the moment. Things like the this is something from the this anime does not exist. I just picked one at random there. Well, they picked one at random and I picked one. Anyway. Now, they do solve a lot of problems and more every day, really, but they are complicated tools. While you can apply them to just about any problem, many problems are not going to be useful for you as someone trying to get content out of it unless you really understand what's going on. So while you do get very artistic pictures like the one on this slide, you can just as easily get a really huge variety in your output depending on what you actually put in. So if you were aiming to get images of people created for your world or game or whatever you're trying to do with the tool, you would probably be looking for more like the left. But if you get the parameters wrong, you're going to end up with abstract art like on the right. And it might not be as straightforward as just a creativity value. If you're sort of using a more complex scan, it could be even down in the training data, and that could be hours and hours of work that needs to be redone just every time you make a change. So if you are trying to dig into GANs, I definitely recommend studying up on that stuff. But some examples of how they are useful in the out-of-the-box form is there's this house GAN. So it generates floor plans. Now, it's a little fiddly. It is someone's research paper, but what you get out of it is you actually get out hundreds and hundreds of floor plans, which can be a really cool way to sort of get inspiration for levels in video games or various other kinds of content where you need to generate a floor plan to sort of lay things out in the world. And then there's this library here, which is a great library for actually generating content for statistical samples. So it'll actually let you take a spreadsheet in. You can just give it a CSV or something else, as anything you can turn into a pandas data cell, and it'll study it and produce a model for you automatically, which is a lot more useful for someone trying to get started. And it's also pretty handy if you need to generate statistical samples. So that's all the stuff I was trying to cover over. And if you are curious about digging deeper into anything, here is some stuff that I actually cut because it was either very, very fragile or more explanation required than I had time for. So if the remaining time has any questions, I'm happy to sort of go back and talk more on any of them.
Hello. We do have some questions, yes. And feel free
awesome.
to drop more questions in the questions chat. If we run out of time here, we can answer them in the text channel afterwards. The first one is, will slides/links be shared online afterwards?
Yep, I'm definitely going to pull out the links and sort of put them into a cohesive document and also share the slides, yes.
Excellent. And of course, the video is always recorded. It'll be up on the PyCon AU YouTube channel, I think you've approved.
Yeah, I see there's the one about the air pressure and the how random the data is. Now, that one definitely has some interesting details in it. So if you saw on the rain shadow one, I don't know if it'll switch fast enough, but if you see on the precipitation one, what it does is it actually uses the terrain height to affect things like the it doesn't have a pressure simulation, but it definitely has things like rain shadowing. There was a large sort of mountain area here, and you can see that it's sort of affecting how much rain we get in these areas around it. So it's definitely got a lot more variables in there, and they do cascade. In fact, you can't generate these things until after earlier layers are generated, so that it is folding these different kinds of data into each process, and it's definitely taking those kinds of data into account. And since there's just a tiny bit amount of time left, I guess if I'm going to answer the GAN question,
So what's your favorite
at the
GAN?
moment, it's sorry.
So the question is, what's your favorite GAN?
Yeah. And at the moment, it would be StyleGAN because there's a lot of very interesting stuff coming out of it, like you saw with the pictures there. You know, it's very amazing that you can get such a huge variety of output from a simple sort of tunable process. It's for the same data, you've got everything from watercolor artistic on the left to very very abstract line art, almost engraving sort of style patterns on the right, and it's really fascinating to see how the same core data and the same model can just produce such a huge variety of output. But yeah, that's just the only one at the moment.
Yeah, great. Thank you so much, Sam. There were a couple of questions left that I'll paste into the hallway chat, text chat version of Platypus afterwards if you want to answer them.
Yeah, happy to answer
next
those
up-
there.
Excellent. Next up at 3:30 AEST, we have Python versus Space Jump with Mars Butfield Addison. Have a nice break, everyone. Thank you so much for hanging out.